Hi everyone, and welcome to the Zenith call on May 8th. We are going to have a presentation from a company called QCentroid, which I got introduced through Keith, which are going to talk about quantum ops, which is a very interesting topic for me. So, Carlos, please take it away.
Perfect. Thanks, Peter, for this opportunity and invitation. And hello, all the people in the audience. It's a pleasure to me to express and to show what we are doing at QCentroid, what is our experience in applying and developing and integrating quantum advanced computing solution, and also having your feedback about our experience to have enterprise-ready quantum operation in complex and regulated organizations. So we are QCentroid. I'm Carlos Kuchkovsky, the co-founder and CEO of QCentroid. We are the orchestration platform for quantum advanced computing. We cover the full cycle from developing, executing, benchmarking, and integrating and deploying quantum advanced computing and AI workflows in corporations. So first of all, the agenda for the session today. After the intro, I want to share with you our experience to have also your feedback about challenges, best practices for adopting and integrating and developing quantum computing and advanced computing solutions. Second, going for the evolution from DevOps to machine learning ops to quantum advanced computing ops, and explaining how, with our experience, are serving customers, helping them to make quantum without the complexity, allowing the full cycle. And also, we will have to have your opinion about how we also are integrating, as all companies, intelligence over the cycle to amend the productivity and also being able to serve our platform for not only humans and teams, also for agents. Previous to create QCentroid, I was working in a big international organization, FINOS, BBVA, where I was leading the research team. I created a lot of experience running different proof concepts in quantum computing and machine learning, and part of this experience and network helped me and our team members to understand better how to create QCentroid. Also, I had the privilege to serve in the World Economic Forum Quantum Computing Council, and I part of the Strategy Advisory Board in the European Commission advisory board for quantum technologies. Also, we are part of different ecosystems like QUIC, Open Quantum Institute, trying to understand how we can serve and guide the evolution and accelerating the adoption of quantum computing from the technology perspective to helping to create strategies. We have been working for the last 3 years. We created the company and we have created different partnerships with new companies, small one, big leaders, to be sure that we provide enterprise-grade quantum platform to help different partners for hardware to developers to organization to be able to collaborate, develop, and integrate. And we say the future of quantum in our collaboration in different international organizations. But let's go for the topic today. To go more deep about QCentroid, we explore and go deep in what is the challenges for organization to adopt quantum computing. We apply our experience in applying classical computing, machine learning, and what are the differences and the similitudes from past cycle of innovation. So we create a big focus in what's mean to define a problem for quantum computing, quantum use cases, how to align teams between product innovation, business teams with science and technical teams, and how to allow the full cycle of execution, benchmarking, and integration and monitoring. But let's go for what super fast view, because you are super aware for the last session about what is happening in quantum computing for finance sector. So this is an interesting report. Probably some of you have the opportunity to read from BIS about potential and challenges of quantum computing in finance. It's interesting how the report separate and classify different use cases. That is one of the big challenges for organization. What is the use case that I can apply quantum computing? What is the cost? And what is the potential impact and benefit to apply this use case? But having different use case, what are the adoption for companies and finance institutions to best practices to adopt quantum computing? So of course, there is a big challenge to create algorithms and to define mathematical model, but we go further in our experience that this is not enough. And from our collaboration, partnership, and from our experience and our customer experience, we summarize some of the big challenges in these 6 points. The first one is several proof of concept are failing in scale. They don't move from the proof of concept states for different reasons, mainly because they are not able to replicate and reuse the proof of concept. and they are having complexity to have the results, technical and scientific results, to be meaningful and comprehensible for innovation and business teams and leaders. The second big challenge that we are seeing is now some of the proof of concept are being working in an isolated way. And the reality is that quantum computing could have a lot of potential in several use cases, but it will not work alone. So it needs to be integrated in a full workflow, collaborating and having the orchestration between classical algorithms or classical and quantum, or machine learning and quantum. The third one that we will deep in each of these is the complexity to compare and benchmark the different combination of algorithms and quantum hardware and classical option, and being able to integrate this with current IT system and continuous integration, continuous deployment, and FINOS framework and system from organization. The last two ones for me are really relevant. That is the misalignment that we have between the research knowledge and the business. Sometimes there is a big gap between what the business team, business unit wants or needs, and the language that quantum expert in science understand and explain. And also the companies now, the quantum native companies that have been working with quantum for the past months or years, have some of these problems, or all of them. And the companies that start in quantum, they are having the moment of wait and see or making blind bets. They don't know from where to start. So we developed the quantum ops for both sides and both kind of companies. So going deep, in our experience, when we work with researchers, quantum researchers, they can know the toy problem or the lab problem from traverses problem, graph, mascad, other academic problem, or portfolio optimization, to put an example. But there is a big distance between what is a real portfolio optimization problem from a business unit. Secondly, the language that they are speaking is really different. So there is not clear comparison between what the business unit needs, what are the KPIs, and what are the scientific KPIs that the business scientific team is working with. And also this problem increase when the corporation organization are not only working with internal teams, but are collaborating with startups or research centers. So this is one of the big challenges that we have been experiencing. One of the second and main important challenges that is start being one of the main difference between machine learning ops is the quantum computing, quantum computing landscape. Probably there are different techniques to make quantum computers, QPUs, quantum processing units, and each of them are having different evolution, and they have different performance about what kind of problems, dimensionality or length of the data or constraints can solve, also the time of execution, the accuracy of the results, and the cost. So there is no clear champion, and it seems that between the different techniques and different vendors, like neutral atom, trapped ions, superconducting, and they have different implementation from different providers, also with different performance and, more important, evolution of performance. So one of the key differences is how in learning we need to benchmark the different models and algorithms and computing options that we have, but this problem start being more complex in the quantum and advanced computing new ecosystem. So now it's mandatory to analyze the impact and being able to select what are the right solutions for a company in a continuous period of time. So this is a slide from McKinsey report, I think 1 year ago. They put a lot of focus in different ways of benchmarking. From the hardware system level, there are different metrics like quantum volume or different metrics to measure the performance, the hardware performance. We have also the algorithms, theoretical benchmarking, like different algorithms that you can read here. And one of the things that is missing is our approach that putting more focus in application level, benchmarking for real use cases that make impact in organization. So this is some of the question, and we put this because it's the question that we are working with several companies when they start or when they continue in quantum generation of use cases with quantum computing is, what are the technologies that I need to use? Do I need to use different technologies? How I know which technology and which algorithms are good for me, and how I can be updated as these technologies evolve. So for this, we put the concrete workflow, how having a use case, companies need to test with classical algorithms and workflows, and also with new quantum algorithms that could be deployed and executed in different hardware options. So we put a lot of focus to translate this complexity in clear metrics for IT and business people to understand. Having homogeneous metrics like the execution price, cost, time, the cost, and also energy consumption, and different metrics that could be added for different use cases. But this is one of the key parts, in our opinion, that make different the machine learning ops to quantum ops, managing this cycle. To put more complexity, as you are following in news, every month, every quarter, we have a paper or a news or announcement how a company, a new one, a medium one, or a top technology company announcing that they are launching a new quantum computing QPU, new technique, or how they are improving or evolving in the roadmap, reducing error correction, or no, in a simpler word, the noise part. So this make the complexity for companies that they don't not only need to make benchmarking when make a proof of concept, is needed to make a continuous benchmarking. Is now companies need to have a full environment for benchmarking in a continuous way, trying to test not only different algorithms, but same algorithms with the evolution and the update of the hardware machines to understand which is better for them for a concrete use case, being able to compare what is the right selection for them, understanding what is the right cost for them, the right execution time, or the accuracy that they need, and select it with this combination. So having this main pain point as one of the main difference from MLOps to quantum ops, also we analyze and work in the full cycle. And please interrupt me if you have any feedback, question, or whatever comment that you want to put in the room. So the full cycle for having a use case, and this is only a snapshot of a proof of concept, need the collaboration of different teams and team members in organization. From having the proof of concept, having access to quantum hardware, that is needed not only to have access to one, you need to have access to as much as possible quantum hardware and being updated and with the modification that the hardware vendors are doing. The integration with this hardware and also internally with different systems in the IT stack of an organization, being able to manage the security and privacy of the data, measuring performance, benchmarking, and being able to integrate and allow the secure and traceable and private collaboration between all the participants. So we put a summary about these challenges, and part of the QCentroid platform is how we solve the accelerate some of the challenges to be able to work in an industrialized way for organization and team members. So we put out a focus to summarize this part of the presentation in what are the current problems that machine learning solves for companies, what are the new challenges that quantum advanced computing put in the table for organization, how this needs evolution of the cycle from MLOps to quantum ops. And it's where QCentroid has the position in the market to continue working to be in the leader quantum ops platform in the ecosystem. You can go to the link here. One more time, have your feedback so we could continue collaborating. That is part of our values as a company. And also having your feedback, how to evolve and go in details of each part of the quantum ops. So to put some of the examples of partners and customers that are using QCentroid, one of them is a member of FINOS, Moody's. We have been proud to be selected by Moody's to be part of their quantum program, also using internally and also for the Quantum Finance Studio, helping them to accelerate the development, testing and benchmarking and integration of quantum and hybrid solution. Another examples that is a different kind of customer for us are quantum hubs. So along the world, there are initiatives funded by private and public money that look for regional or national collaboration and development and technology transfer for research startups and academia to organization, corporates for SMEs, and all have similar things. They want to get access to hardware in the cloud or on premise, and they want to allow the collaboration between companies, corporates, and startups. So we are also serving hubs around the world with good learnings and great experience. So going deep now in explain how we are implementing the quantum ops with QCentroid. step by step, and we can also go real for the platform to see not only a slide, but also the real work of the QCentroid on live. So in one side, there are different ways to explain the functional architecture of QCentroid. In one side, we have providers, hardware providers that we connect. We allow integration through APIs and also different integration methods with IT and technology system and company system. And we allow the cycle of experimentation, the cycle of production, development, and also how we allow the continuous iteration between these cycles. So from development, experimentation, benchmarking, moving to production is something is meaningful to put to production and having a parallel environment to continue experimenting in a continuous way. Another vision, more technical stack of the platform. In the bottom, we connect to a hardware computing system with quantum, but also to classical GPUs and also new FPGAs, photonic system. In the top level, we have the business orientation to use cases, and in the middle, we allow all the orchestration in a secure, enterprise-ready way. Summarizing all the things that we are explaining, how we are. So now is the moment you have questions related to the how to implement the different part of the quantum ops with QCentroid. And tell me if you can hear me right. Yes, Peter, is all okay?
Yep.
Perfect. Okay, I will continue. Perfect. So starting with a real examples, and we are going to spend 5-8 minutes in here, and let's go to the live platform. So one of the main challenges that company has is trying to have in a common part the use case definition. So we allow at the beginning of the platform to have a real concrete definition of the business use case and also the information from the mathematical approach and the technical IT and data details. I will explain later. The second part is companies don't only work in a use case, so they start having more than use case, similar to what's happening now with LLMs and machine learning. Companies will start going to dozens of use cases, so it's meant to have a proper management of use cases, understanding who is working with use case, and having the aggregated view. Having the aggregated view later, when you have a use case, having aggregated view is being able to work with data or assign data set or connect to a third party or public data set. And in our experience, is a good practice before moving data protection department or security department to anonymize data to be able to work with synthetic data. Not all the machines available are secure at this moment and confidence to send data without a lot of work, with dummy data or being able to generate synthetic data. For this case, we have also allowed to connect synthetic data platform for synthetic data methods for different. When we have having a good management of the catalog of use cases, and the part that company has the challenges is related with the workers, time. You need to maintain the hardware integration and also maintain access to the hardware and managing the API keys in a secure way. We'll talk later about how we manage computing time, budget, and traceability. So I was thinking that now that I move out from the presentation, I can start making the same thing through the live platform. So tell me the setup of the screen is good for you and you can see the platform. It's okay?
Yeah, I can see the screen.
Perfect. So the platform, as we were saying, trying to follow a conceptual approach in different parts. One, we have use cases, and these use cases can be divided by organization, team, or also a public catalog inside the organization or with the partners. We have the solvers that are like the algorithms, similar organization, but it's important to also add the repository, called repository connection. We have dataset, and we have hardware providers dataset and reports. So a classical follow that people or teams used to do is, depending if they want to start from scratch in a use case or they want to work in a use case that is being generated. If they want to start, they need to fill the use case description, mathematical approach, and different IT data metrics. And let's go for a concrete example of a use case in finance. So you can search, filter different use cases by your type and also by the algorithms or use case type. So going for a concrete use case to explain the full cycle. So this is a asset diversification use case. Probably all of you know about the problem. The use case for the feedback with our customer, we put together first the use case definition. So what the business unit want, what they are looking for. Secondly, we put together also what the scientific team is think that they can solve the problem, first in a mathematical modeling approach. And later, the IT team or the same development team is important to define the compromise of the use case in the way of data. What is the data input, data output, and accuracy variables that the use case is going to have? So it's a JSON schema where we define for a use case what are the input data. So with this, we can start having example data set for this use case or adding new data set that we can transform or create in a synthetic way. So after generating the use case, the platform create enterprise level API for being able to connect or execute the use case. So now that we have the use case, is the moment to start two things, or adding new solvers. In this case, we add different algorithms as an example. Each of these boxes is a connection to a repository of code that is Git-based, that you can connect the code that your partner, your team had been created, or that you are creating. So it's easy, really easy by step to add new solvers. That is selecting if you have a repository of code or some solver connected to the platform, or following the steps to add new solvers. And another way to see this vision that is more visual understood or understandable is having the use case with the API, different algorithms, implementation of algorithms connected to different machines. That could be classical simulators. So in this way, instead of being the need to connect one by one or being able to execute, we allow companies to upload or work with different data sets and being able to manage the full cycle in an API way and also in a visual way about what are the solvers that they want to execute or they want to test. In this case, let's put this example. So we help the companies to move. We have an error that we are not allowed to use one of the algorithms. And it's something how we control who can get access to what things from visualization to execution. So trying to replicate the same thing, but with other algorithms. So we allow for teams to manage the different datasets that they have, or adding different metrics, or by JSON. So in this case, let's pick this one. It's important in our experience also to start making the traceability about the execution of a use case. And if I want to go start setting up different variables, more technicals about the number of jobs, and also putting more comments in here that is. And also we can set up different variables from a solver or hardware setups. So in easy steps, you can manage what now teams need to manage not only by technical things, but they don't have the traceability about what they are doing, or they need to spend a lot of time understanding what are the variables that they need to have. We provide a summary about what is going to be executed. And now what we are doing at this moment is connecting all the repository of codes, adding libraries that each solver needs, also adding from the security HSM the API keys for each vendor, and creating on-the-fly containers, confidential containers to start sending the payloads to the different hardware vendors. So in this case, let's take a view about execution that we made some days ago, because now we are waiting. Some of them are in queues, or some days, some of them are, we need to wait. So we have the hook to the different computers. But the way to visualize this, when you are now executing, when you have executed this, having the technical results but also being able to provide a visual benchmarking between the different algorithms to being able to know what is better for IT, but mainly also for business decision. And also being able to tag, to have traceability about what are the different experiment tracking that, or try to manage experiment tracking of use case in a period of time. So to summarize, use case definition, use case program management, how we are not only managing one use case, how we can have the different use cases also in collaboration with the business, technical, scientific team, understanding what should be the priority, the complexity, the data availability. So having all this in one place, being able to have a clear roadmap about what use cases organization want to start implementing and executing. And also super important, how before executing a use case, how companies could understand what could be the cost of this execution and what will be the cost of a use case for a full quantum program. So being able to add different metrics and understand what should be the cost. And having this, we are moving an Excel to a dynamic collaboration executor benchmarking tool. So we are moving the roadmap to a concrete use cases where you can start adding more algorithms, executing, and so on. Do you have any question until this moment? Okay. So one of the last part that we have a lot of focus is two important things that is aligned with the finance management. So each team member has the capacity, the organization manager of the team, capacity to delegate computing time or computing credits to different team members or projects. So being sure that no one is spending more than what is assigned, and having a concrete billing traceability about what is being spending by user, by use case, by different solvers, by hardware. So being able to distribute, manage all the quantum program and use case development in a end-to-end way. The more things that we have in other modules of the platform is the capacity to, one of the challenges that developer has also, the scientific team, is before executing in real quantum computers, that sometimes you can spend thousands of euros in few seconds. It's a good practice that we recommend to be sure that things can execute in emulators or simulators. One of the challenges that team has when they are doing this in the local computer is they don't have enough memory, enough GPUs in their computers. So for this, we create a development environment on the cloud, so we can assign on the fly computing and memory for developers, so they can work with as much several GPUs to test different algorithms over emulators, and later having the cycle to start deploying or in the platform and in executing real computers, but having a step-by-step process to be sure that it's being executed in real machines, what is working and what has been tested before in simulators. And the last two parts before going to the last section is how it's important not only to have the benchmarking of one execution that is really relevant, but a use case used to be executed in a period of time, and as the performance always evolves, is a never-ending benchmarking, updating execution, benchmarking process. So for this, we provide a clear way to have the experiment tracking for the use case with different data set, executing a use case algorithms with hardware with different data set, different combination, to be sure that it's able to track the updates in some part of the algorithms, hyperparameters or hardware, what is the impact that is generating, and selecting what are the best options for a company to integrate in production. And all this that we are showing is based in enterprise APIs. So the platform could be connected to current continuous integration, continuous development tools inside our organization, and also with mobile application or whatever platform that want to or execute or access to the final results of the algorithms and hardware, or updating, uploading solvers, all the functionalities that you have seen in the platform, you can get access through APIs. So stopping here a second, for the companies, we detect that also there are companies that are at the beginning process of the quantum ready journey. They don't need yet the orchestration, integration, and benchmarking because they need to start defining what are the use cases. So for this, in the last month, we have been developing our own assistant based in AI agents that help companies to move week or months work to look for what are the right use cases, what are the benefits for me, the potential cost, what could be the algorithms and hardware for them to being able to generate in minutes. So first, we allow companies to self-make their quantum readiness assessment, where they are comparing with some peers from their industry, understanding what should be the best practices for them to work internally. And secondly, through conversation agents, they start exploring what are the use cases that could be more relevant for their strategy, their department, or organization. Later, being able to start mapping for a use case what could be potential algorithms that could solve this use case and what are the machines that are the best one or the right one to be connected and executed the algorithms on. And having also the forecasting of the budget cost calculator of execution. All this is how we allow the full cycle of quantum ops from business innovation, technology science, and IT team, having the full cycle and how we allow having the continuous capacity of having the right combination of algorithms and hardware, allowing collaboration. And I will stop here to have your feedback or going deep in one of the parts that we can make some concrete demos, other part of the platform that we are not showing. Can you hear me, Peter?
Yes, yes, we are with you.
Perfect. So I don't know if there are some questions in the room or feedback.
So if you need help getting unmuted, let us know. We will help you unmuted. Okay, no questions. I think you can continue.
Okay. So maybe, Peter, you can help me to make a light demo because we have two things, as I was to being clear. We know that company, to summarize, can have a use case, and we put two examples about how we are now launching the platform. The platform is full operational. It is working, could work on SaaS and on-premise with the enterprise-ready finance needs and levels. But also we are updating and launching new functionalities every quarter. So this quarter we are launching and improving our AI assistant for the platform. So we have two parts. One, and we can make this experiment or we test with Jupyter is one. This is mainly for the newest companies that are looking to start. So I hope that you can see my
Yep.
chat. So maybe I can write, Peter, and you can tell me if you can read what are the use cases that you are interested in finance, on other sectors, or let's continue in finance, some concrete finance area that you are looking to explore how quantum could work.
Yeah, let's talk about asset management. That seems
Asset
an
management.
interest. Yeah.
So this is mainly because we are adding copilots for all the parts from the business people, from developers. We are helping them also to make circuits, to select algorithms, to integrate and understand the results. So we have 5 assistants. This is one of them. So now, okay, about Peter, about the asset management.
Definitely the portfolio optimization.
Okay. We call this the quantum engineer consultant. Sometimes it's going deep in the questions to try to have more info.
Let's try to minimize risk. We are in that world that we have to start minimizing risk.
Yes, it's a good way to start with. Optimization, are you interested or do you want other crazy solutions?
Optimization techniques. That's
Okay.
interesting.
So
I might learn something for my day-to-day work.
so therefore, is having two main cycles. This is the first one when the platform is empty, so a company don't have use cases. So we help the company to create the use cases. But more important is the orchestration part of the Quantum Ops. That is, after a use case, what you need to develop your algorithms, code, connect to hardware, and sell it. So now our junior quantum consultant has been proposed different potential use cases for this.
Wow. Okay.
But this is for the starters. We have the
I
starters.
know, I understand.
Yes. So we can add one of them, and to continue the example, I have this that I made this before for trading, but the other things that we have this empty, we help the teams to start filling this. So one part that is complex I can have, and I can add my code for a classical algorithm that I work in here. So I know I want to understand what could be potential good algorithms and hardware for my use case. So we have the other agents, that is the junior quantum research assistant, that start understanding the use case and know the different algorithms that are now being working by the academic and community and the different hardware. So we start, the junior researcher start proposing some potential algorithms that could work for your problem and could be potential hardware, and trying to start giving first look about what could be performance and the potential cost of this use case with this hardware. So now you can start selecting this and moving then to the development to start creating your own code, and also moving to create your technical input and output data. We have another assistant to start helping you to define the input and output data and generating synthetic data on the fly. So the goal is to help companies to accelerate step by step when they are native in quantum, accelerate their benchmarking and integration, and where they are starting, trying to help them to start from months to hours or days. So now we can generate data set for a use case, start being quantum ready or adopting quantum in a fast way. I hope that you like it, Peter.
Yeah, no, this was fun.
Yes.
And the whole thing was like, in 5 minutes.
Yes. So we have, as I was saying, main summarize from my side. For Quantum to be ready, we need new tools, as we are having evolution of hardware, new algorithms, and the setup of hyperparameters. So we need new cycle, new tools, and we need to be able to integrate with our current tools and new AI agents, as we are seeing that all the companies are integrating, that also we allow connection and work with our agents, but also with third-party agents. So how companies need to move to quantum ops to being able to capture in an enterprise way the quantum opportunity, and how it's important for companies to being able to understand if they are starting, what are the right use cases, if they are moving further, how they develop faster use cases, the security to connect with hardware, and being able to launch the same use case with different data set over different hardware, benchmark in second, and being able, and this is only for visualization purpose, if you are executing several times and you know that you like this one of these combination that you had for this education problem, you have been running different option. We have shown that I love this one. So now, and this is visual, and we know that companies will never do that. We can go and select which is the combination that we want to respond when you are calling to the API. So you can call to the API to have parallel execution, or only select what are the combinations that you prefer to put in production. So this is an example. For the one that are more interested, you can find more information in our web page, and also in all the documents that we are doing to try to promote and collaborate in quantum FinOps for adopting quantum in scale. You can go and also go deep in our posts and articles that we are doing our quantum ops. And also our proposal for quantum hubs. And as I was saying, the documentation. You have full documentation about how to start and all the integration that you can execute with the platform API. So you can use what in the way that you prefer. And I think that we have 10 minutes left. But for me, thanks for having your attention today. I hope that you find interesting our approach to quantum ops that you can also apply to integrate in your internal organization. And also, we are looking for collaboration for companies. So call us if you want to go deep into a topic, you want to share experience about what you are doing, or get more info about experience and how you can move from quantum exploration to quantum reality in days and weeks and not quarters or years.
Reach out to you or QCentroid, how they should do that?
This is a great question. You can go to our webpage that there are different links to apply for a call, or also you can ask for start having a trial of the platform, or you can write me through my mail here or through LinkedIn.
Perfect. So thanks everyone for joining. As usual, I will publish this on YouTube and looking forward to see you guys on the next Zenith call. Thanks everyone for joining. Have a nice day.
Thank you. Have a great day.